Many thanks for being given the opportunity to talk today at this conference among such interesting speakers. My name is Jamie Campbell and I'm a medical doctorate student at the University of Edinburgh. I'm presenting our package Cadmus, a pipeline for biomedical full-text retrieval, which was developed over the last 2 years with my co-first author Antoine Lane. Cadmus is credited in Greek mythology with establishing the Greek alphabet in between slaying dragons. We similarly want Cadmus to provide the substrate for research in biomedical natural language processing. There's so much information locked up within journal articles. Biomedical texts use specific language that lends itself well to automated extraction, and the UK has provided a formal legal framework that exempts non-commercial research from many of the constraints of copyright protection. Exploiting this resource is challenging. Publisher APIs can be combined, but each has its own idiosyncrasies, and articles are often provided in different formats. There are examples of open access repos like we've seen for COVID-19, but these are the exception and have a low percentage of useful articles for a given purpose. Our package can generate a bespoke collection of full-text academic publications. You can design the search query or provide a list of PubMed IDs. We've used the BioPython Entree package to build our search, but this step could be swapped out to query other databases. I'll show the success rate for retrieval, which is good, especially when linked to a research institution. False positive detection and document parsing aim for a clean representation of the text, moving beyond the title and abstract, facilitating granular analysis. It's suitable for scheduling to update an established collection, lending itself to a living review or analysis of a fast-moving topic. So how does it work? We provide a search query string as you would for a PubMed search. Queries are sent through the eSearch tool using the BioPython library and subsequently using the request module in Python. Metadata is retrieved in JSON format and the critical fields are parsed like PubMed ID, PubMed Central ID and Digital Object Identifier. Then the collection is structured in a Pandas data frame. We then collect as many full-text URLs as we can find for each record through the Crossref API and in the PubMed linkout section. We then retrieve the documents using each record's identifier as we work through a number of avenues. We use established repos like PubMed Central and Europe PMC, following the guidance for each API's polite use. Then we use publisher APIs when these exist. Only after these efforts fail do we try and scrape the article from the full-text web page. Effectively, this is a gopher stage, making the program go for each full text by trying avenues in order of politeness. The format of each retrieve file is identified and processed accordingly. PDFs are processed using the Tika library, which is Java wrapper from Apache. HTML and XML are processed using the Python library Beautiful Soup. Parsing aims to extract the body of the article and remove all links, tables, and references. Each candidate file is evaluated for size and word count by comparison with the abstract and for any blacklist tags indicating a failed request. The parsed text is saved in the data frame and the raw file is stored locally. We've used Cadmus to download over 100,000 articles, but here we show a test of the program using 4 disease-associated gene name searches. Our performance within the University of Edinburgh sits at around 85% for all years and increases to 89% in the last decade. This improvement is commonly observed and likely represents increased provision of text and data mining formats in recent history and improved web indexing, which allows us to locate the target file. Open access performance means running the program on a home computer and Wi-Fi, but still providing personal API keys. This approach lags behind due to the altered redirection of requests, but still offers a reasonable representation of the target corpus. Cadmus is an open source tool for generating large-scale biomedical corpora. We are keen for collaborations and feedback on the package. To find out more, please visit our GitHub page at github.com/biomedicalinformaticsgroup/Cadmus or send an email to the group at ian.simpson@ed.ac.uk. My co-author Antoine Lane is presenting Cadmus as a poster with additional details and results, and we would love to hear what you think. I'd like to acknowledge our funders at the Medical Research Council and the Simons Initiative for the Developing Brain. Much appreciation to the developers of all the Python libraries and the APIs that we utilize and rely on so heavily for this package. Many thanks to my supervisors, Professor David Fitzpatrick and Dr. Ian Simpson, for their guidance and input on this project. Thank you for listening to my talk, and I look forward to answering any questions shortly.